A shed in northern Illinois. Cold steel under a fresh coat of paint. An access hatch bolted shut since before the moon landing. Dust on a throttle nobody will ever push again. Behind that hatch sits the most powerful locomotive Union Pacific ever owned. It burned the cheapest fuel in America. That fuel was grinding the engine apart from the inside, and it never stopped. Union Pacific bought 55 of these. At their peak, they moved about a fifth of the railroad's heavy freight across Wyoming and Nebraska. 53 went to the scrappers. 2 are left. Neither one will ever turn over again. Have you ever driven past a machine like this and wondered why nobody kept it running? Drop it in the comments. This is what American Iron Works covers. Subscribe so you don't miss what's next. In 1948, Union Pacific had a problem that steam could not solve and diesel could barely afford. The railroad's money was made hauling freight up Sherman Hill, the long climb west out of Cheyenne. Tonnage was rising. The big boys could pull it, but a steam locomotive needs water towers, coal, ash pits, and a crew that knows it personally. Diesel was the obvious answer. Every other railroad in America was already buying it. The problem was arithmetic. A road diesel in 1948 made 1,500 horsepower. To replace one big boy, you needed 4 or 5 of them, and each one came with its own price tag, its own maintenance bill, and its own set of parts. Union Pacific did the sum and did not like it. So the railroad tried something no other freight carrier in the world would attempt. It bought a jet engine and bolted it to a frame. General Electric had been building gas turbines for aircraft. In November 1948, GE finished a demonstrator, a double cab machine that made 4,500 horsepower from a single turbine spinning at 6,900 revolutions per minute. Union Pacific tested it for nearly 2 years and ran it more than 101,000 miles. On the 1st of April, 1949, weeks after that demonstrator started running, a man named David S. Neuhardt took over as General Superintendent of Motive Power and Machinery. He would hold the job for 22 years. Every turbine Union Pacific ever bought, ran, and scrapped happened on his watch. The first 10 production units arrived between January 1952 and August 1953, numbers 51 through 60, $540,000 each. 15 more followed in 1954, with a recessed walkway down the side that got them nicknamed verandas. Then 30 more, built between August 1958 and June 1961, rated at 8,500 horsepower apiece. Railroaders called those the big blows. There was one problem the horsepower could not fix. A turbine that size drinks, and the tanks on the locomotive were nowhere near enough to cross Wyoming. So Union Pacific went to the deadline and started cutting up steam locomotives. From 1955, the railroad pulled tenders off retired steam engines, rebuilt them to carry 24,000 gallons, and coupled them behind the turbines. Range stopped being the limit. Within a year, the machines were running all the way east to Council Bluffs, Iowa. Remember those tenders? They outlive everything else in this story. Starting one of these was its own procedure. The crew lit the turbine on ordinary diesel fuel and spun it up to 80% of its maximum before switching across to the heavy stuff. The whole sequence took about an hour. Here is the part nobody puts in the specification sheets, and it is the only number that ever mattered. The turbine did not run on diesel. It ran on bunker C, the tar-like sludge left at the bottom of the barrel after a refinery has taken everything valuable out of the crude. At room temperature, it has the consistency of molasses. It had to be heated to around 200 degrees Fahrenheit before it would even flow through a pipe. Nobody wanted bunker C refineries produced it, whether there was a buyer or not. Diesel fuel in the 1950s cost between 10 and 12 cents a gallon. Bunker C cost 2. Union Pacific was not buying fuel. It was buying a waste product at a fifth of the price to run the biggest locomotives on the continent. The numbers the railroad put on paper were brutal. Operating a turbine cost $69.19 per 1,000 gross ton miles. A diesel cost $84.03. Steam cost $145. The turbines burned roughly twice the fuel of a comparable diesel. It did not matter. At a fifth of the price per gallon, twice the volume is still cheaper. That is an argument no mechanical department in America could refuse, and I don't think any of us would have refused it either. On those numbers, the turbine wasn't a gamble. It was free money sitting on the ground. Union Pacific published its own figures in 1956. 25 turbines, 6 million miles in 4 years, 227,950 hours of firing time. One single machine had logged 17,266 hours by itself. Availability sat between 78 and 80%, and each unit was covering 8,000 miles a month. The machines worked, the economics worked, and the whole time, something in that cheap fuel was destroying them. Burn residual oil, and you are not burning clean hydrocarbons. You are burning what is left after everything clean has been taken out, and what is left carries sodium and vanadium. In a diesel engine, that ash goes out the stack. In a turbine, it does not. A gas turbine works by throwing combustion gas across a wheel of blades at enormous speed. Combustion chamber temperatures ran to 1400 degrees Fahrenheit. Exhaust left the stack at 850 degrees, moving at 150 miles an hour. Now put grit in that gas stream. The sodium and vanadium in bunker C attacked the combustor cans and the nozzle vanes chemically, corroding metal that was already glowing. The solid ash sandblasted the blades mechanically, thousands of times a second, for every hour the machine was under load. General Electric built those blades from mnemonic ATA, a nickel alloy developed to survive the inside of a jet engine. They eroded anyway. Union Pacific pulled a turbine for overhaul every 4,000 to 5,000 hours. Read those two facts next to each other. The fuel that made the locomotive worth building was the fuel that was taking it apart. Not a design flaw, not a manufacturing defect. The saving and the damage were the same substance, arriving at the same moment every second the machine did its job. This is the part that gets me. Union Pacific knew, and the railroad spent the next decade trying to get out from under it. The first attempt was propane. On the 31st of May, 1953, Unit 57 was converted to run on it. Propane burns clean. No sodium, no vanadium, no ash in the gas stream at all. The turbine loved it. Number 57 covered roughly 69,600 miles and nearly 3,000 turbine hours on propane before Union Pacific converted it back to bunker C on the 1st of January, 1954. 7 months. The fuel worked. Moving it and storing it across a railroad that spans a continent did not. The second attempt was oxygen. Someone worked out that if one turbine made 4,500 horsepower, 2 turbines coupled to a shared fuel tender would make 9,000. Units 59 and 60 were paired up. They ran fine in open country. Then they entered a tunnel and the trailing turbine flamed out. The lead unit had eaten the air. A gas turbine at full load consumes an enormous volume of oxygen, and inside a bore in the Wasatch, there was not enough left in the tunnel for the second machine to breathe. Union Pacific abandoned the pairing and bought more diesels instead. The third attempt was the one that should never have left the drawing board, and it is the one they actually built. In October 1962, Union Pacific rolled out a locomotive that burned coal. Not oil, coal pulverized into dust and blown directly into a turbine. President A.E. Stoddard announced it as a partnership between the railroad, General Electric, Alco Products, and an outfit called Bituminous Coal Research. The machine was assembled out of 3 dead locomotives. The cab was a rebuilt Alco PA-1 passenger unit. The turbine rode in a 101-foot body sitting on the chassis of a Great Northern Electric. And behind it came the tender-off Challenger steam locomotive number 3990, carrying 61 tons of coal. End to end it ran better than 200 feet, roughly the length of a Boeing 747, and weighed 733,000 pounds. They fitted an ash separator to catch the grit before it reached the blades. The coal-fired machine ran fewer than 500 miles before inspection found the combustor nozzles and the turbine buckets destroyed by corrosion and erosion. Fewer than 500 miles. Across 20 months, it accumulated 488 operating hours and 21,848 miles, most of it not on coal at all. It was struck from the roster on the 15th of March 1968. That number doesn't fit the story most people know. Which part surprises you more, that they built a coal-burning jet engine at all, or that it lasted less than 500 miles? 3 ways out. Clean fuel they could not distribute. More power they could not feed air. Cheaper fuel that destroyed the machine faster than the fuel it replaced. Union Pacific was trapped by a decision made in 1948, and there was no version of the turbine that escaped it. Then the market did what the engineering could not. Bunker C was cheap for one reason: nobody had a use for it. Through the 1960s that changed. Refineries improved their cracking processes and produced less residual oil. The petrochemical industry found applications for what was left. The Suez Crisis pushed fuel costs up around 9%. By the late 1960s, the price of the sludge had quadrupled. The turbines still burned twice the fuel of a diesel. Only now the fuel cost real money, and the entire argument for the fleet, $69 against $84, inverted. Meanwhile, General Electric had solved the horsepower problem the turbine was bought to solve. A single U50 diesel made 5,000 horsepower in one unit. No preheating, no hour-long startup, no exotic alloys. Union Pacific bought 23 of them between October 1963 and August 1965. And here is what General Electric did with the turbines it took back. It pulled the trucks and bolsters out from underneath them, the frames and wheel assemblies, the part nobody photographs, and built the U50s on top of that running gear. Then sold them to Union Pacific. The railroad bought the underframes of its own turbine fleet a second time, carrying a different locomotive. Not one of those 23 U50s survives either. The retirements came in waves: 4 units in August 1968, 1 more that autumn, 7 through early 1969, 4 more before Christmas. On the 26th of December 1969, turbine number 7 left Cheyenne for North Platte, Nebraska. That was the last one. No ceremony, no press release, no photograph anybody thought to take. The final 14 were struck from the roster in February 1970. Union Pacific made no effort to preserve a single one. 53 of the most powerful locomotives ever built went to salvage yards in Kansas City, Houston, Riverside, and Salt Lake City, and the 2 that survived did so by accident. In September 1971, a company called Continental Leasing bought 6 turbines for scrap. It was tied to Western Contracting of Sioux City, Iowa, run by a man named H. Everest. His crews cut up 4 of them. The other 2 he gave away. Number 18 went to a railway society in Kansas City in 1977 and reached the Illinois Railway Museum in the early 90s. Number 26 went to Ogden, Utah in March 1986 and arrived on the 10th of July, 1987. Volunteers from the Golden Spike chapter repainted it by hand. The marker beside it says the locomotive ran more than 1 million miles between Council Bluffs and Ogden before it was retired on the 28th of February, 1970. You can visit both of them today. Number 18 sits at Union, Illinois. The museum's own condition card reads, "Incomplete, cosmetically restored, not operational." It still has its turbine. Most of what surrounded that turbine was stripped out before the museum ever got it. Number 26 sits at 813 Wall Avenue in Ogden, painted, static, silent. Neither museum has a restoration planned. There is nothing to restore them to. The men who knew how to light one are gone, the parts stopped existing decades ago, and no working example was left for anyone to learn from. The engines themselves did not all die. Western Contracting pulled turbines out of the machines it scrapped and installed them in an ocean dredge called the Western Condor, finished around 1977. Some of what hauled freight over Sherman Hill went to sea, and the tenders, those enormous fuel cars, were cut down from retired steam locomotives in the first place. After the turbines went, Union Pacific converted them again into water cars, then into auxiliary tenders for its surviving steam program. One of them runs today behind Big Boy 4014. That is the whole story of this program in one object. The only piece of the turbine fleet still moving in America is a fuel tank riding behind a steam locomotive it was built to make obsolete. Whether Union Pacific was wrong is still an open argument, and I don't think the evidence settles it. One reading says the engineering was sound and a fuel market killed it. The numbers worked for 18 years and changed for reasons no mechanical department controls. The other says the machine was never economic once you counted the overhauls, and cheap fuel just postponed the bill. Both readings fit the same facts. What neither one changes is the shape of the thing. Union Pacific did not buy a locomotive in 1948. It bought a position in a fuel market and wrapped 8,500 horsepower around it. When the position closed, the horsepower had nowhere to go. Every machine built around a price is carrying a countdown it cannot see, and the strongest thing about it is the part holding the clock. Once you notice that, you'll find it behind half the industrial history in this country. And that's what American Iron Works does. Subscribe so you catch the next one.